All right, Stefan, it's your turn.
All right. Well, as I said, feel free to ask questions as we go. Just interrupt me. I will have you in my periphery, but feel free to just unmute yourself and say one moment, and we'll pause there and cover things. So I wanted to put together a talk to try to summarize everything that has happened and what the future outlook looks like for working with SQLite on Rails, given the advancements that have happened in the last year and a half for the most part. Just to do a quick introduction for those of you who I might not have met yet, my name is Stephen. You can find me at Fractaled Mind on all of the social platforms. I am currently a senior engineer at a company called Prevail Legal. But probably if you do know me, you know me for my open source work. I have contributed a number of features to Rails and to the SQLite Ruby driver, and I have a number of gems that I maintain. Those are sort of four of my most popular ones. A lot of my work, especially in the last year and a half, has focused on how Rails and SQLite can and should work together. And in particular, that work has culminated in the release of Rails 8. So I want to take some time to sort of walk through what makes Rails 8 a uniquely powerful web application framework for building with SQLite, why that's interesting, and what that means for us. So Rails has always been a batteries included framework, and it ships with a wide range of components. And some of those components require persistent data of some sort in order to work. We can call these the data-bound components of Rails, and there are 5 of them. And a full-featured application is going to need some data stores to back most, if not all, of these components. Now, Rails is a flexible framework, so it comes with multiple adapters for various data stores for each of these components. But if you were to just run Rails new for Rails 7.1, you would get these as your defaults. So there's lots of options, but these are the defaults that you get. And there are a few different things to note about these defaults, but the most sort of important summary is that these are not production ready and plug and play solutions. You have to do work to either make them run or make them production ready. And one of the primary focuses for Rails 8 was to make the default out-of-the-box experience for the data-bound components of Rails both production ready and plug and play. And that was unlocked by building out the trifecta of solid gems. So with version 8, when you run Rails new, you get a notably different set of defaults. The suite of solid gems provide production-ready defaults for these central data-bound components of Rails. Now, of course, the solid gems offer database-backed but database-agnostic adapters for active job, active support cache, and action cable. So you can use MySQL, you can use Postgres, but what I'm interested in is the power that unlocks for working with SQLite. And specifically, I'm interested in SQLite as a database engine because I think it pairs so nicely with the philosophy of Rails as a one-person framework. As David outlined in his Rails World keynote last year, in 2023, I mean, Rails aims to be a bridge over complexity that allows even the smallest possible team, right? Even just you as an individual to build full, rich, and valuable web applications. And SQLite supercharges this aspect of Rails. Now, I say that, but I know that we have had years and years of people consistently saying that SQLite simply doesn't work for web applications. But the fact of the matter is that this is a myth. But it's not without its foundations, because SQLite in the context of web applications is indeed easily misunderstood and misused. You see, unlike much of modern software, SQLite cares more about backwards compatibility than it does about enabling newer and better features by default. The maintainers care deeply that a database file created 2 decades ago can be opened by SQLite 2 decades from now. And this is a key reason why, among other things, SQLite is the storage format used for digital data by the United States Library of Congress. But for all intents and purposes, this does mean that when you use SQLite today without any tweaking or configuration, you are effectively using SQLite as it was configured when it was first released in 2004, over 20 years ago. And it's fair to say that in 2004, SQLite was not well suited to being run in a web application. So SQLite needs fine tuning. But over the last 2 decades, it has added many features that do make it suitable for web applications. So I want to now jump into what fine tuning is needed to use SQLite in a web application and how Rails has made those defaults built in for us as of the release of Rails 8. A lot of this is covered in a longer blog post that I have which is based on a talk I did previously. So there's lots of slides as well, which you can find on my blog. But we're going to cover 4 key details. And if you want to read the whole piece, there's the URL, there's a QR code to go into it. There are 4 key elements to reaching what I might call SQLite performance nirvana. So let's start with number 1, write-ahead logging journal mode. Wall mode matters because it is way faster. What this change means is that it allows us to have concurrent readers. So by default, the original journaling mode that SQLite had has a pretty hard limitation on accessing the database. Sure, you can spin up multiple connections to the database, but only one connection is able to interact with the database at a time, whether reading or writing. So you're completely linearly queued up to interact with the database. There's no concurrency at all. There's no parallelization at all. The wall journal mode was added in the last 2 decades, and it allows your application to spin up multiple connections to the database. And if some of those connections need to make reads, they can do that concurrently. So if you have a high traffic web application and it needs to run and it's doing a lot of reading, right, which is the default, of course, typical distribution of work in a web application will be about 80% reads and 20% writes. You will see a massive difference when you switch from the default journal mode to the write-ahead log journal mode. So that's the first, simplest, most important thing to change. And this has been in Rails since version 7.1. So this is the default for every SQLite connection that your Rails application spins up. And in fact, this is just one of a handful of default pragmas. Pragmas are the configurations for a SQLite connection that Rails now sets up. And there's a little QR code there. I have a blog post sort of detailing why these six and what they do. But the long and short of it is that these six configuration values, these six pragmas, are going to optimize your connection for modern day performant interaction with the SQLite database. We're going to enforce foreign keys. We're going to use the journal mode. We're not going to do a full sync back to the file system after every single write. We're going to batch those. We're going to increase the shared memory size. We're going to increase the overall journal size and set our cache size to be a bit bigger as well. As I said, the blog posts cover these things in detail, but the key point here is that Rails is doing this work for you to ensure that you are doing the best possible thing to interact with SQLite in 2025. The next thing to cover is immediate transactions. So let's talk a little bit about what the problem is and why we need to solve it. If we consider a transaction like this, which is like a default transaction you might see, SQLite will actually do something that was, at least for me, quite unexpected. And it's all based around the fact that while you can have any number of concurrent readers, SQLite still has a limitation that you can only ever have one connection writing to the database at a time. So writes are linear and sequential. And in order to support this, SQLite has a write lock, and only one connection can acquire the write lock and hold the write lock at a time. So when it comes to transactions, SQLite has to make a decision about when and how that write lock is attempted to be acquired. And the default behavior, so if you just say begin transaction, the default behavior is that a write lock will be acquired, or more specifically, attempted to be acquired, whenever the first write operation inside of that transaction is encountered. So if you were to do only reads, right, begin transaction, select, 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 it would never try to acquire the write lock, and it would be able to concurrently do all of that work inside of that transaction alongside other connections doing other reads, perhaps inside of transactions. The problem for web applications, and specifically for Rails applications, is that we basically only ever wrap operations in transactions when we are doing writes. So there is no benefit to allowing for the possibility of a read-only transaction, or at least there's very, very little benefit because it's quite rare. But there is a problem, and the problem comes from the fact that because we are inside of a transaction, when that connection tries to acquire the write lock, if another connection is already holding the write lock, SQLite has no way to attempt to recover because it has already acquired a snapshot of the database for that transaction. And so it can't just retry this one operation inside of the transaction, because if it does retry, that retry will happen against potentially a different snapshot, and that'll break one of the core acidic guarantees that relational databases provide us. So when you attempt to acquire the write lock inside of a transaction, if that connection can't acquire it, that connection is being held, which is quite common in Rails applications, right? We're going to naturally spin up by default 5 different connections to the database. If you have any decent traffic, at some point, 2 different connections will be trying to write to the database at a time. Rails wraps every single write in a transaction, again, by default. So you're going to hit an error where it'll just say database busy, database locked. So if there are people who have worked with SQLite in the past in Rails applications, I know for a fact that you hit this error all the time, and it probably was the bane of your existence. It was the bane of my existence. So how do we solve this problem? The key is to tell SQLite when we begin a transaction that we want to begin an immediate transaction. And by explicitly declaring that this is an immediate transaction, we force SQLite to attempt to acquire the write lock immediately. And so if it can't acquire the lock yet, it simply queues this query to retry acquiring the lock later. But what the query that we're attempting to try again is the query that grabs the snapshot. So it's safe to retry. So when we begin an immediate transaction, we have the ability to lean on SQLite's native retry mechanism, which means we don't have to make changes to application code and we can deal with concurrent attempts at writes and having them line up to be serialized, right? Run in order. And this like makes a massive difference. I had a test application where I ran different tests against it. So I just ran some simple requests with different levels of concurrency, right? So just like one concurrent request, 2, 4, 8, 16. And in this test, I was using 10 different Puma workers. So the number of Puma workers sits in between here. You can see even at just 4 concurrent requests, almost half of my requests were 500s. They were errors. Once I got to 8, like the majority of requests are actually errors. So like this error case is completely at odds with any degree of like concurrency in your application, which makes it obviously not production ready. But as soon as we make this fix to force all transactions to be immediate transactions, we see the errors basically go away. We're going to talk a little bit about this 1% in a bit. But errors from this particular problem do completely go away. And so that is why we need immediate transactions to make working with SQLite in the context of a web application where you're going to have a connection pool done. And this is a feature that was released in Rails 8. So now, by default, every single connection that your Rails application makes will do this. If you need to backport this functionality, if you have a Rails 7.1 or earlier application, so long as you're using version 1.6.9 or later of the SQLite 3 gem, all you need to do is set this value in your database YAML. This will get passed down to the SQLite gem as it initializes any connection and will ensure that every transaction that is created as an immediate transaction. So you can backport this feature really easily to earlier apps if you're not on Rails 8 and you can't get there anytime soon. But with Rails 8, you don't need to do anything. It'll just be handled correctly. So let's jump to the last two and talk a little bit more about the problems that have existed with working with SQLite in the context of web applications and how Rails now fixes them by default. So both of these last two steps are related to latency. So running these tests again, I'm looking at P95 and P99 with different levels of concurrent requests. And we see here at 16 requests, which is the moment where I've jumped over the amount of Puma workers I have, right? So more requests are coming in than Puma workers to handle them. Once we get to that point, our P99 skyrockets. Boom, it just takes off over 5 seconds. If we double the number of concurrent requests, that pushes down to P95 as well. Now, if that 5-second number is tickling something in your brain, it tickled something in my brain, it is indeed connected to the default timeout value that you will see in your database YAML file when you run Rails new. So let's break down a little bit what's happening. Why is it that as our application is put under more concurrent load and it overflows the number of Puma workers we have, that our latency basically becomes our timeout? Well, To understand what's going on, we need to understand that that timeout value in database YAML is being converted into this SQLite command, right? So we're setting a pragma value for the busy timeout to 5,000 milliseconds. You can read more about this pragma command here at this link. And in order to get to the heart of the problem here, we need to break down what's happening on the SQLite side and what's happening on the Rails side. So on the SQLite side, we talked previously about the built-in mechanism that SQLite has for error correction whenever you have busy exceptions, right? So two different connections try to write to the database at around the same time, and they can't. One has to go first, and then the other has to go second. And SQLite has a mechanism built in to resolve that conflict and figure out which goes first and which goes second. And this is that solution. So when you set your timeout, SQLite will attempt to reacquire the write lock for the connection that hit the busy exception using a kind of stepped back off. And if it cannot acquire the write lock within that timeout window, then and only then will the busy exception be thrown back to the application. So your connection comes in, tries to do a write, the database is busy. Instead of your application receiving an error, it'll just keep waiting. And it'll wait up to this amount of time, 5 seconds in our case is what we've set it to. And if at any point in those 5 seconds, the write lock is released and the connection retries and it's able to acquire it and then it performs its work, your application doesn't receive an error. It just had increased latency. So this is fine and this works well. It's a nice solution. But this interacts with some of the peculiar aspects of a Rails application built on top of Ruby. Because we have to remember that SQLite is an embedded database, right? It's quite different from Postgres and MySQL, which are client-server databases, because it is actually running embedded within your Ruby process. It's not a separate process that you are talking to over either HTTP or some sort of inter-process connection on the same machine. And this is what drives its speed, right? You have zero overhead. You don't have inter-process overhead. You don't have network overhead. This is what makes it so fast. But it does get a little bit complicated because by default, the SQLite gem does not release Ruby's GVL when it calls into SQLite. And for the most part, this is a reasonable decision, but for the busy timeout, it does greatly hamper throughput because if we imagine two different workers, typically we think of I/O as happening external to the Ruby work. But in the case of SQLite, that work actually lives inside of the Ruby process. So what we want is this, right? This is natural concurrency. So when worker one is doing I/O, worker two can do Ruby work while worker one is doing I/O work. And once worker one's I/O work is done and it needs to return to Ruby, the handoff can happen and we have better saturated our resources through concurrency, right? This is what we want. But because we're using an embedded database, by default, that doesn't happen. And we have blocked these two workers. So worker two can't do anything until worker one has finished. So this is the problem. And this is why we see these timeouts, because some workers are just blocked for the entire 5 seconds, then SQLite errors, and that error bubbles back up to our application. So how can we solve this? Well, fundamentally, what we need to do is we need to release Ruby's GVL whenever the SQLite connection is waiting to reacquire the write lock or to reattempt to acquire the write lock. So we could rewrite the busy timeout logic in Ruby and use the sleep function. And Ruby sleep function does release the GVL. And so while a query is waiting to retry acquiring the lock, Ruby's GVL is released, and we can allow other Puma workers to do Ruby work, while this particular connection is waiting on the database. So if we just make this change, we see our P99 come way down, right? This is a massive improvement. And this is the importance of having a non-GVL blocking timeout mechanism. And this too has been released as a part of Rails 8. But if we look back at this, we see it is starting to creep up again. And this is where we get to the importance of a fair retry interval. And we can see this more clearly if we focus in on the P99.99, so like the very worst requests in our benchmark. We see again like this sort of linear increase in latency. So our slowest queries under increasing concurrent load are growing. We have a growth curve and we want to flatten it. So in order to flatten it, we need to understand why this is happening. And as the problem title suggests, the issue is that our Ruby reimplementation of SQLite's busy timeout logic keeps a problem that SQLite has itself, which is that it penalizes older queries. And this is going to kill our long tail performance because responses will get naturally segmented into batches that have young queries and old queries. And those old queries are just going to get older and older. But to explain more clearly what I mean, let's step through this delay logic ourselves. So the logic that we had for that busy timeout has this delays array. And the very first time a connection attempts to acquire the write lock, if it can't, it'll wait 1 millisecond. When it tries again, that second time, if it can't, it'll then wait 2 milliseconds. If it still can't, it'll then wait 5 milliseconds. Well, what this means is that on that third retry, right? So after this, we're going to have a 10 millisecond wait. And so imagine that right at the moment that it attempts this attempt and is then told to wait 5 milliseconds, that at this moment, a new write query is sent to the database. Well, this new query is going to immediately attempt to acquire the write lock, no delay. And if it's denied, it'll wait 1 millisecond. And if the write lock is still held, it'll then wait 2 milliseconds. So this new query will have 2 or 3 opportunities to acquire the write lock before our original connection even attempts again, right? So this stepped back off has the effect that once a query is forced to wait even just 3 retries, it is now much more likely to never acquire the write lock if there is a steady stream of write queries coming in, because it's just going to check way less frequently. And that will give new queries a massive advantage. And so you are going to see that like you'll basically always, if you have steady writes coming in, you will always have one connection that just fully times out. It just never is able to acquire the write lock. Because as it gets older, it's more likely to get older. And then it is older, so it's even more likely, and so forth and so on. So the solution here is to sleep for a consistent amount of time. If we just always sleep for 1 millisecond, regardless of how old, quote unquote, that is to say, how many retries have already happened, regardless of how old a connection is, if we always sleep 1 millisecond, then we don't penalize old queries and we don't favor new queries. All connections have the same odds of acquiring the write lock next. And so if we do that, we actually don't need all of this extra logic. We can simplify things down to just this. And this is the actual code that is in version 2 of the SQLite 3 Ruby gem. And the key detail, of course, here is the consistent sleep. Now, this releases the GVL, which is solution one that we needed, and it has a fair retry mechanism. And if we run our benchmarks again, we see indeed a flat latency curve. Of course, we're going to have latency for the very worst requests, but even as the number of concurrent requests grows, even as it crosses our worker threshold, we don't see a penalized latency even in the very worst request, right? This is P99.99. So this is why having a fair retry interval is so important. And this too is a default in Rails 8. So Rails 8 is really, in my understanding and in my opinion, a quite unique release for a web application framework because it marks the first version of Rails, and as far as I know, the first version of any web application framework that provides a fully production-ready SQLite experience out of the box. And this is due to a spate of work in this area over the last year and a half. There have been so many pull requests by the Rails community over the last year and a half to bring all of these features into the framework. But what we have now is a really powerful single person framework because across these four tools, we have built in defaults to replace these various third-party tools. Right? So the picture for the data-bound components of Rails in Rails 8 is notably different. You can go all in on SQLite and back 4 out of the 5 data-bound components of Rails with SQLite, and you won't have any compromises on performance or on features. And for me, this is really exciting because this unlocks this application architecture, which is one of my absolute favorite things, if I'm being honest. I love powerful simplicity, and few things are as simple as having a single server with all of your application's dependencies as well as your application itself that is able to serve a feature-rich modern web application, but without needing to figure out how to do all of your Docker setup. And then, oh, I need to actually set up Docker for each of my third-party services. Now I need to coordinate how each of these Docker containers, my MySQL container, my application container, my Redis container. I need a different container for my pods that are going to run my Sidekick Rails instances. Do I use Docker Compose? Do I use Kubernetes? Where should I deploy this? How many different machines? Like so many questions. We now have the power as individuals to radically simplify our stack, have our application be our source of truth for everything, drive all of our features through a single code base with a single dependency, but not sacrifice on basic power and performance. And this is all here, right, in Rails 8. So we've covered now like the core changes that are in Rails that make SQLite a production-ready database engine now in 2025. But I want to talk about some additional considerations, like taking a step back from just Rails, the framework, so that we can make sure that if we decide to use this technology stack, that we are doing so responsibly. And of course, the very first place to start is with backups. You need a solid backup mechanism in place, and you need it on day one. And I know this because I have accidentally deleted my production SQLite database. And trust me, resilience is something that you should have set up immediately. There are a bunch of different options, but I think that the best tool for the job is a tool called Lightstream. Lightstream is a utility that allows you to, well, stream every update to your SQLite database or databases to any of a number of different bucket storage systems. Or you could even just set up your own FTS server if you wanted. So you can get point in time backups and you can pay quite cheap storage costs. And in the Ruby ecosystem, we have a gem that wraps this executable for us. So it's very easy to download and it's easy to install. And you can find more details on the gem at these links. So this gem also uses a Puma plugin to manage this replication process. So it truly is a plug and play solution. And it even ships with a verification job that you can schedule to run regularly to ensure that your backup process is continuously running smoothly. To break down what all you get when you install the gem, you're going to get the configuration file for Lightstream itself, which is using these environment variables that you can configure in Ruby using the Lightstream configuration block. So you could, as in this example, put your credentials in your standard Rails credentials and then bind them to Lightstream such that everything works. And then it gives you rake tasks to actually run the different things you would need from Lightstream. So you can start the replication process, or of course, just use the Puma plugin. If you want to restore a database, that's quite easy. Call the restore command, pass in the name of the database you want to restore. And as I said, it also ships with a verification job. It looks like this. You can set it up as a recurring job if you're using solid queue, which just has recurring jobs built in. I run it in my applications like at 1 a.m. UTC every day. And it just makes sure that it makes a little change to a hidden table inside of your database, waits some amount of time, by default 10 seconds, for that change to get replicated up to the cloud storage service. It then calls restore. So it creates a copy of that database on the local file system. And then it opens that new database up and checks if that change is present. And if all of those things are true, then it reports true. And what this means is that you can verify that changes are replicated up to your server within a certain window. You can verify that restoration of your backups works correctly. You can verify that a restored database is openable. It's a proper SQLite database, so the SQLite CLI can open it. And you can verify that when you do open that database, it contains that recent change, which I think covers basically everything you would want to ensure that your backups are actually there and actually working. It also comes with a Rails engine if you want to just see the basic information about the Lightstream replication process. So a little visual UI for you. I think it's quite full featured and also relatively simple. So I think it strikes a really lovely balance, and you should absolutely make sure that you do something for backups if you want to build a SQLite on Rails application. For those of us who might have simple applications that we are running and hosting and we want to reduce our costs, but we just think it would be too much of a hassle to upgrade the application all the way to Rails 8, we can backport all of these features that I've discussed, as well as some others that I haven't yet discussed, and I'm about to, by using the Active Record Enhanced SQLite 3 adapter gem. So if you just add this gem, it will automatically backport all of these features, the ones I've discussed, like those performance optimizations, as well as just bringing some new features that the SQLite adapter in Active Record was lacking. Just to walk through some of those here, you can have deferred foreign keys. So that means that the constraint check for the foreign key will be done once the transaction is committed. This is, a bit of an edge case thing, but when you need it, you really need it. It's in Rails 8, but if you aren't on that version and you need that feature, you can get that backported. You also have the ability to define virtual columns. I remember when this was announced as a feature for Active Record for Postgres, it's like, this is so cool. and it wasn't available for SQLite, and I just presumed it was because SQLite didn't support the feature. When I dug into it, I saw SQLite does support the feature. No one just has taken the time to implement it in the active record adapter for SQLite. So this is a really useful feature. You actually can do stored and unstored virtual columns fully. So it supports the full range of that functionality. You also have the ability to specify custom returning columns. This is a feature that is explicitly available to you if you're using the insert, insert all, upsert all methods. But this feature also is the foundational feature that allows virtual columns to be hydrated for you when you create a new record. So these two things are actually tied together. It helps to ensure that when you create a new record, you get the active record instance back. It will have those default values from the virtual columns present for you in your active record instance. It also backports the ability for you to specify custom pragmas in your database YAML. This is another feature. This is in Rails 8. You just have it there, but if you're on an earlier version and you want this feature, you need to specify a couple additional pragmas aside from the default 6. You can just do that declaratively in your database YAML. So if you are on an earlier version of Rails, the Active Record Enhanced SQLite 3 adapter is a really useful gem to add. I would definitely bring it into your application. Similarly, another gem that is quite useful if you want to take advantage of the large collection of extensions that SQLite has and supports. You can make use of the unofficial, but nonetheless useful package manager for SQLite extensions. It's called SQL Package. This is, again, just a Go executable, so I have wrapped it up in a precompiled binary Ruby gem that has a Ruby interface. So you can just add the gem, run the installer, and then it will give you these commands to allow you to install packages. You can go to sqlpackage.org and .org.com, one of those two, to see all of the different extensions that are available. There's over 100, there's tons of them. In this case, if you want UUIDs, it's easy. And when you're using the gem, you can also declare which extensions you want to load for which connection. So in this case, if I put it on default, every connection will have it. You might have some extensions you only want to load for like your queue database or your cache database or your primary database or who knows what. You have full control there. Some additional things. The SQLite 3 Ruby gem allows you to actually set your compilation flag. So if you want a custom compilation of the SQLite executable, you can do that, and you can do it directly through bundle configuration. Here is an example of a little bit of a performance optimized compilation of SQLite. I have a whole blog post on this, talking through what these different flags do, why we have these 6 flags. It doesn't make a massive difference. You maybe get like a 2%, 3% performance improvement if you do this, and you're removing some features, like you can't call the like operator on blobs, or different things. But when you have the need, like it's valuable for your application to have a 2% performance improvement, you can do that. And here's how you can do it. One of the other things I really love about using SQLite in a Rails application is that it also like unlocks some unique developer experience opportunities. The very first one that I came across that I still just love to this day is having a isolated database per Git branch. So I can completely avoid the problem of having schema conflicts when working on my features and then checking out other developers' features to do reviews, and our migrations are all mixed up. Just put every Git branch in its own database, and it's super easy to set up. You can put ERB in your database YAML, and in Ruby, you can call CLI commands, right? So we can just like get the branch name. That's really easy. And then in your development config, you can just make sure that your database is activated. This calls the prepare rake task programmatically. You can even layer stuff on top of that. I have in the blog post here some different scripts just using bash to actually move data around between databases, right? So you could have like a fixtures database, for example, and sort of use that to seed later created branch databases. There's all kinds of extra things you can do. It's quite cool. One of the other things that I really enjoy is that for me, really leaning into the philosophy of having radically simplified infrastructure for my applications started to open up new horizons for what was possible. And solid errors is a gem that came out of this realization that in the same way that solid cache could replace Redis and solid queue could replace Sidekick and solid cable could replace Redis, right? And I didn't need these external services that I talk to over HTTP. I could just have a SQLite database and a Rails engine that presented a little view to track data that I care about. So one piece of data that I care about are errors that occur in my Rails application. So instead of sending them out to Honeybadger, sending them out to AppSignal, sending them out to Sentry, why don't I just store them in a SQLite database right next to my application and put a little Rails engine UI in front of it? So Solid Errors is a really straightforward, simple, lean gem. It's quite easy to set up. This is all that it takes. You set up your own errors database. You then run the installer. You can configure it. You can even have it send emails if you want. This is like the one little extra feature that there's there. And you mount the engine. And it gives you a simplistic UI, sure, but like not super simplistic, right? You're going to get a rich backtrace. You're going to get chunks of code, all of the information about the error when it occurred. It tracks multiple occurrences. You have the ability to resolve errors. They disappear unless they occur again, and then they come back. It, for me, has been the only error tracking I need for the kinds of applications I am building with SQLite. And this kind of mindset you can apply to so many things. And this sort of is where we turn towards the future, right? Like what more can we do as a community and what more can be done and what work is being done. So we could apply the same philosophy to other bits of data that we might need. I started working on a solid metrics gem, right? Initially just focusing on active record queries. So what are all of the queries? You know, how many times have they happened? How long have they taken? What's their average? What's their P99? I know another developer working on a solid logging gem, same philosophy, right? Instead of sending it out over HTTP to some third-party service, just put it in a SQLite database and put a Rails engine UI in front of that database. I think there's a lot of possibilities there when you really start to embrace this philosophy of like, what is data that's useful to my application that my application produces that I could store in a local SQLite database with a simple Rails engine UI instead of piping out over HTTP to some high-powered third-party service that you might not need at this point, right? Maybe you need it after 1 year and you've gotten successful, but on day one, maybe you don't, and you can save yourself some money, save yourself some complexity. But there are other things. One additional sort of performance feature we could work with is trying to isolate connection pools. Let's talk a little bit about why this would be interesting. This isn't like a requirement to have a performant Rails application, but it would improve performance because we know that SQLite in wall mode supports multiple concurrent readers, but there's still only one write connection allowed at a time. Well, we know that our active record connection pool is a fixed size pool. So it is possible that you could saturate your connection pool with write connections and therefore block read operations. Just to sort of talk through what I mean by that, if you imagine that you have a connection pool that only supports 3 connections, and you get 5 different queries that come in at about the same time, and 3 writes are earlier than the 2 reads. Well, these 3 writes are taking up all of the connections in the connection pool, and they're going to have to serialize themselves. So one, and then the other, and then the other. And these 2 reads are just going to have to wait until connections open up for them to perform. But this is a bottleneck at the level of active record, not at the level of SQLite. SQLite could, if you had a flexibly sized connection pool and just say like, oh, I've got reads, like shove them in. SQLite would handle them fine. You could send 1 million reads at SQLite at the same time. It would handle that concurrency just fine. So what would it look like to try to avoid this bottleneck altogether? What would it take? I did some experimenting here to try to imagine actually setting up a reader and a writer connection pool where my reader sets up read-only connections exclusively, and my writer only has one connection because I know that SQLite only supports one, so why allow 3 in and then have them wait? I can sort of move the write lock up to the active record layer, which will actually be a bit faster because it's not a file system lock. If you set up connection pools like this, you can use Active Record's multiple database support. So you can tell your application record that it can connect to the writing and reading connection pools. And as I think about it, I realize that what I really want is analogous to deferred transactions and immediate transactions. I want deferred requests, right? So instead of immediately at the very beginning of the request deciding which database I talk to, I want every request to default to using the reader connection pool. And then whenever they need to write to the database, then and only then switch over to using the writer pool for just that operation. And this is a bit different from the default way that Rails sets up connection pooling or multiple databases, pardon me. The default way that Rails sets it up is like, each request figures out which database it talks to, and it talks to that database for the duration of the request. And what I want is something more fine-grained, but I was able to make it work. You can set up the same sort of multiple database middleware resolver. It can be quite simple, right? We're going to just always point it to the reader. But then we could patch active record. If we patch that transaction method, we can wrap our call to super with a connected to call and point that particular operation to our writing connection pool. And if we do that, we do see some improvements. It's kind of sporadic. Blue is isolated connection pools here. So like at 16 requests per second, we do see like a noticeable difference. Some of the others, like when it's not a lot of concurrent requests or we have a ton of concurrent requests, the difference isn't very noticeable. Here in the middle, right around the number of Puma workers we have, it can be noticeable. But it does require patching active record, and you have to figure out where all you need to patch it. So like this particular patch, for example, does not solve the problem if you call insert or insert all or upsert all. Those don't go through the transaction method, so they don't get sent to the writer, and so you get errors. So you would also need to patch those methods appropriately. So there's still some kinks to work out there, but this is a experimental feature that is in the active record enhanced SQLite 3 adapter gem that you can just turn on now by setting this configuration variable. So if it's something that you want to experiment with, if you have like a high performance need and you aren't using inserts, or you just want to patch those yourself or contribute them back to the gem, this is something that you could experiment with, and maybe over time we can make this more resilient. One of the most exciting features for the future of SQLite on Rails right now is actually building a proper parser. So this is a project I'm working on actively right now. I was working on it earlier today. I will work on it again tomorrow. And the idea here is to like have a fully 100% SQLite compliant parser that returns an AST. And the reason why this is needed is that SQLite itself does not have a AST generating parser. Its parser generates directly bytecode instructions that are immediately executed by its internal virtual machine. There is no abstract syntax tree. So there's no way to get at the information of how SQLite understands the structure of your SQL queries, which can be limiting for different kinds of features. I found myself starting working on this because I want to be able to introspect a database and understand all of its structure. And while SQLite does give us some introspection capabilities, it doesn't give us all of them. And so at the end of the day, if you want to know the structure of a table, you have to just read the create table statement and parse it. There's no way to get all of the information out of it otherwise. So having a parser that returns a syntax tree opens up all kinds of possibilities. I'm building this parser to actually provide a concrete syntax tree. So it'll allow us to build syntax highlighting of SQL on top of it. Being able to fully introspect your database will allow me to do some more interesting and powerful database migration work. Try to improve that. And who knows all the different other features that could be there. So this is going to be cool. I currently have create table statements are being parsed into an abstract syntax tree. That is, you can see all of that code in GitHub now. I'm working on making the syntax tree a concrete tree at the moment. And then after we get that refactoring done, we will turn to parsing all of the other statements. So this is something that is real. I'm over the hill. Like I'm 100% confident that it is doable. And that is work in progress. The last other sort of thing that could be interesting to explore for the future, this is the number one question I get anytime I talk about building Rails applications with SQLite, is like, what about if we gave every single tenant their own independent SQLite database? Which is indeed an interesting idea and something that is available in SQLite in a way that is simpler and more direct than it would be trying to use Postgres or MySQL. And all I can say right now is that this is being worked on. So the future is bright on this front. But all in all, this is why I love working with SQLite. And I hope that after this exploration, you better understand and appreciate how well SQLite pairs with Rails as an engine for creativity, for building. And I hope that you feel confident that you can, and maybe even should, build and run your next Rails application with SQLite. And just to close, if you happen to be interested in this topic, or if you just want to give me some money for the last year and a half and these 5 different gems, I do have an ebook. It was written in Rails 7.1. So it covers a lot of details that are now just built into Rails 8, as we have done here, and how to bring them into your application. So if you have a Rails 7.1 or 7.0 application, it's really useful. But if you just want to have a better understanding of what is going on, how all those different features are actually working, as well as just breaking down all the details of like how to set up Lightstream, how to set up solid errors, stuff like this. That ebook is available on Gumroad. But aside from that, I just appreciate your time. And I'm done.
Thank you very much, Stefan. That was a great talk. And I'm sending a virtual clap See you. Is there any question, guys? By the way, I really liked solid errors thing. I will use it my SQLite hobby project. Definitely.
Yeah, it's one of my favorites as well.
Yeah, it's a good thing. It's free, by the way. So I think the other things, Honey Badger and Sentry, should be at some price.
Yeah, Honey Badger is actually a sponsor of this project because they understand, they have the same philosophy that I do, which is that every single Rails application should have error monitoring on day one. It is table stakes for building an application and maintaining it over time. But not every application needs to have full featured service oriented error monitoring on day one. And some applications can't, right? It costs money. Those are businesses and those are services, and they have lots of servers to serve lots of customers, and they have their costs and their employees. And like, of course, it costs money. And they have many features that Solid Errors does not have and will never have. But I think it is so valuable to make the barrier to entry on the floor to allow any developer with any application to have useful, like featureful error monitoring on day one. And if that application gets traction and gets maybe some financial traction, and you're like, oh, for error monitoring, I actually do want to upgrade to a full featured service, you have a really easy migration path to something like Honey Badger. So it is free. It's always going to be free. It's also like not going to add any major features. But it is not like antithetical to using something like Honey Badger. It is just a step on the road, and it's a step that I think needed to exist. And I think the same thing is true for something like solid metrics or solid logs or any of these things, right? Like we should have full featured Rails applications that a single person without any money can build and maintain. And then if they have the need, if they have the traction, they can upgrade the parts of their stack that they would need at that particular moment as needed, right? Like maybe at some point you do decide to migrate from SQLite to Postgres or to MySQL. Maybe at some point you do decide to migrate from solid Q to Sidekick. Like who knows? From solid errors to Honey Badger. You should have that flexibility. That's part of what makes Rails beautiful, right? The omakase support. But anyway, all that to say, I really love solid errors. I use it all the time. But also, like at the company I work for, Prevail, we don't use solid errors. We use a third-party service because we have needs that require features that like a full featured third-party service provides that an open source gem doesn't. But bringing that barrier to entry lower, I think is so valuable. And if you have ideas for like, oh, here's like some data that my Rails app generates, that it would be nice to provide this kind of easy, lean, free solution for. I think that the Rails ecosystem is eager for these kinds of tools. And as solid metrics and solid logs come out, I think that they're going to get equally good traction that solid errors has gotten.
Yeah, you have another project called SQLite dictionary, but I couldn't see this thing. I mean the solid errors. Maybe you should add this one. Some people are using, and they can add. I mean, if I'm using the solid errors in my project, I can add the solid errors feature to my project on the your
Yeah, that's a good point.
SQLite dictionary thing. So I have a question about this thing. And do we have another database to store these errors and these things, or we are storing the main database?
No, I call it solid errors because I am completely following the philosophy and structure of the other solid gems. So it's
Mm,
totally database agnostic. You can use any database engine, Postgres, MySQL, SQLite,
mm.
MariaDB, Oracle. Like, if you connect Active Record to it, you're done. And similarly, as you can with Solid Cache, Solid Queue, Solid Cable, you can determine which database you want to use. So you can put everything in a single database, or you can split out separate databases, right? So by default with Rails 8, it splits out separate databases, which is the correct default, in my opinion. But for example, if you wanted to use solid errors in an existing application that uses Postgres, then you would just point it at your single big Postgres instance and have all of your data live there. And it supports any combination of those things that you want.
Yeah, cool. Thank you. Any questions?
I
I have
have
a
one. Yeah, you go first.
Thank you, Olcan. Thanks so much for the talk, Stefan. I wanted to ask a relevant question to the Ender's last question. Why should I like separate my databases by my use case? Like, is it convenience? Is it performance? Or like, do you have any benchmarks when you have like a single database or database per use case, like solid cache and solid queue?
Yeah, so the answer is basically performance, right? So SQLite is limited to a single writer per database. So the easiest way to get increased concurrency and or parallelism is to have multiple databases, because then you can be talking to your cache database at the same time you're talking to your primary database, and there's no conflict. You can do that at the exact same time. And so you immediately get increased concurrency. Now, of course, there is a trade-off. However, that trade-off is basically already paid for, because essentially every Rails application that exists today is already talking to different IO backends for these different services. It is the rare and exceptional Rails application that would be using a single database instance to back the central data-bound components of Rails, right? The default is that you're going to use Sidekick for your jobs, and that's using Redis. Then you're going to use Redis for your cache. But of course, like, you need different cache eviction policies for your jobs and for your cache. So you're going to want to set up different Redis databases for that. So you're talking to different Redis databases, maybe in one Redis instance, but there's certainly going to be different Redis databases, or they should be if they're not yet. And then you'll be talking to maybe Redis, maybe Postgres for your cable, and again, different eviction policies. So even if you were using Redis for all of them, you're going to be using different Redis databases for them, because you need different configuration for each of them. And your application has already sort of swallowed that complexity of, I need to talk to different IO backends. So when you embrace SQLite, if you keep that trade-off, which I just think most Rails developers understand how to write applications that way, right? We're already used to our background jobs not living in the same database as our primary database records. Then you get the benefit of increased concurrency. If you put everything in one SQLite file, then you have to serialize writing your records for your primary database, with writing cache entries, with writing jobs to be enqueued, with writing messages to be sent over the cable backend. So if you have any decent amount of traffic and you're using all of those features, you're going to notice a real latency slowdown. It's not going to be unusable, right? You could absolutely start any application that way, but it is going to have a ceiling, and you can immediately remove that ceiling by going from one SQLite database to support all four components to four different SQLite databases for each component. And if you start on day one with those 4 different databases, it's going to be a lot simpler if you ever do reach that ceiling. And so you just have a higher ceiling for how much load your application can handle before you feel any pain that might force you to change some of these lower level infrastructure decisions.
I think it might be also important for backups. For example, you might not want to backup all your databases. Maybe you just want to backup your production database, and you might maybe need different backup strategies for different databases. Right?
Yes, that is true. It's completely reasonable to say, oh, I don't want to back up my cache database. I just don't want to spend that money, right? You're going to have to put it in S3 or somewhere if you're using Lightstream. It's fine if it gets lost and then I just build it back up. So I'll save the money. And by having a separate database, you have the easy ability to say, I'm going to back up my primary database. I might back up my jobs database, but I'm not going to back up my cache database or my cable database. And so you can save some money, and especially in applications where you might have a really large cache, or you're sending out a lot of jobs or a lot of cable messages, that could actually have a meaningful impact on the cost of you retaining those backups in whatever bucket storage service you're using. So that's a good point, and that's true. In general, it just gives you that kind of flexibility. And I think the trade-off is relatively low.
We have one question on the chat. Attila wrote, did you try random interval waiting in fair retry interval? Right now it is waiting like 1 millisecond, but have you tried to use random between 1 and 5 milliseconds to like benchmark and see, I guess?
Yes, I need to finish and publish the blog post that's been sitting on my machine for probably 6 months now. I tested a whole bunch of different retry logics, and there are differences. But the short answer is that they aren't notable enough to, at this point, in our opinion, and by our opinion, I mean the people contributing to the SQLite 3 Ruby driver, to merit complicating that logic. But I do have the benchmarks. I tried a number of different ones, and random is indeed a bit faster when you have a lot of throughput. There was another one that was faster. It wasn't like the absolute fastest with like the largest amount of throughput. I can't remember the strategy that was, but I should go remind myself why that post isn't done and just post it. Because I covered at least five or six different algorithms for figuring out how long to wait to retry.
All right then. Sorry, Olcan. I need to close the recording at that point. Maybe we can continue to talk, but it doesn't matter. We don't need to store it. Okay, Olcan, you can.